available to everybody after as well. I'll probably post them on the Sched page. But this is a quick overview of some medical applications of 3D printing. Before I submitted this talk, it was pre-COVID-19, so there was all of that face masks and stuff that we'll end up talking about. So there's one other person just starting to join. We'll wait for them and then we'll go on. Some background information. My name's Steven. I'm a mechanical engineer. I work alongside medical devices, and this is something that I think is pretty cool, that they can be 3D printed. It's not just like you don't have to mass produce a whole bunch of anything now to get something that's beneficial for both the patient, the clinician, and everybody involved. So quick overview, what is 3D printing? It's a process of creating a physical object using layers of material. So instead of subtractive manufacturing, which is the more traditional like CNC process, right, where you're removing material, with 3D printing and additive manufacturing, you're adding material to make one giant one piece. So you're almost growing it, which is pretty cool. It started in the mid 80s with SLA, stereolithography, and that's still used to this day. Formlabs is a common consumer grade machine out there that has something like that, and those are UV photopolymers, but there's a whole bunch of other technologies out there, and some of the devices and everything that we're going to talk about can span across these different technologies. Just these technologies are just different ways of producing the devices, right? So there's SLS, which is selective laser sintering for polymers, so plastics. FFF, which is the generic term for FDM. Most of you guys have seen those little desktop hot glue guns that move around. Binder jetting, which is where you have some sort of base material in a powder form and then some sort of adhesive, build them up. Laser powder bed fusion, which is where you have a metal powder and you shoot it with a very powerful laser and it melts it together. Super cool. Whole bunch of welding just on a micro scale. And then electron beam melting, which is similar to laser powder bed fusion, but uses electrons moving very fast instead of a laser. So it's a little different, but it's all pretty much, those are just different methods. Oh, come on. All right. So what do you manufacture when you can manufacture anything, right? Often 3D printing and additive manufacturing, they say complexity is free. That's something we'll talk about. It doesn't really cost you extra time to build something more complex than it would be to build something simple. So some of the benefits of additive and 3D printing are you can build patient-specific medical devices. You can build low-run or limited usage medical devices. Some of these are necessary, but they're not necessarily profitable for mass manufacturing. Some of these devices that individuals need, it doesn't have the prevalence of a knee replacement, where it's very profitable for your big prosthetic companies to go in there, figure out how to make artificial joints and make them well. Something that affects 1 in 5,000 individuals isn't profitable for them. So this is a chance for 3D printing to come in. One of the earlier usages is models to aid in visualization, right, with both patient education, right? So you can understand what's happening with your body, right? And understand what the doctor's talking about instead of just looking at those scan images. There's also something, they can also do preoperative planning, right? So the doctor will have like a physical model and they'll be like, okay, this is where this is. How do we work with this in 3D and figure out the best approach to it, which we'll talk about. And then recently, COVID-19, maybe it's just the circles I'm in, but I've seen a whole bunch of calls for like, let's 3D print this, like 3D printing to the rescue. It's going to help. The biggest thing I've seen is these face masks, and this is a design that's published by Prusa, who makes one of the very common desktop FDM printers. These are something that's, you can print at home for your medical providers. So the first thing we'll talk about are low-run medical devices. And this is a device that is come out of the University of Michigan. It is a 3D printed trachea splint to treat tracheobronchomyalgia. That's a rare condition where around 1 in 5,000 babies has like their trachea collapses. You can see that over here, how it's malformed and it collapses under its own weight. So when the trachea collapses, right, you can't get air into the lungs, and then obviously that's a bad situation. And the typical treatment for that is they intubate the babies for up to 3 years. That's common, right? So that's 3 years where the baby has to be in the hospital on a ventilator just so they can live. And that has a lot of consequences with regards to their quality of life, their developmental timeline, all of that. So this is a device developed by them. I have a better picture of it, of something up here. This is printed out of a bioabsorbable material. So what they do is once they figure out that the baby has this condition, they can intubate temporarily, and then they can go in and do the surgery and include these. And because they're bioabsorbable, they just have to be placed inside the body. They don't have to be removed, which is good. And the design also allows it to flex and grow with the child. So you don't have to have a surgery to remove it like you would if it was metal. And this is something that you just, 1 in 5,000 cases, something this specific. I mean, it doesn't look that complex, right? But this is just not something that you really want to manufacture in mass, right? You can't injection mold a bunch of these for 1 in 5,000 babies and then just have them on hand. So this is a cool, really cool opportunity for 3D printing to come and improve the quality of life for a lot of individuals. The next thing we'll talk about is patient education, right? So medical models can help clinicians and patients get a full view thanks to a 3D model. If you guys have ever looked at like x-rays or like DICOM data, any like those scans, it can be a little confusing. It's just good to have like a good model, in 3D, so you don't have to rely on this 2D projection and stitching that 3D model together in your head. So it's really useful to show to patients, hey, this is what's going on. This is where that tumor's at. This is all that stuff that you need to go on and see. This is an example of some tumors on kidneys. This is at like the bottom by your kidneys. So all of these red areas are areas that are tumors. So this is some individuals' scan data placed on a stand, and then they colored these afterwards to show where they're at. So this is something like, hey, this is where you had those tumors, and it's really cool to be able to go in there and see them and be like, hey, this is why we have to go about this the way we have to go about it. This is a link right now I want to go to. I didn't want to pull the pictures from that website. It's from the Mayo Clinic, but they have a pretty intense imaging department. So these are some of the models that they have. This is just a long. This is a model being printed on what's called like an objet machine. And then this is like a clear view of a heart. They don't really have. This is a rib cage. We'll pull this up. So this person had lung cancer towards the top of their lungs, and this was a tumor that was very close to the bone growth. And then you can also see some nerves here in this. So it was good that the surgeons, instead of going into surgery, being able to see, okay, there's the tumor, there's the nerves. Cool, we don't have to worry necessarily about hitting those nerves and cutting them out, because those nerves control like your whole arm. So those are kind of important to leave intact. These ones right here, they could have a higher chance of success for removing it just by seeing the geometry ahead of time. So there's a video here. I'll post that in the slides. I couldn't figure out how to get sound to work through it. So I'll let you guys check that out on your own, but I think that's it's a good example because the patient is also a doctor in this case. Now we'll talk more about patient-specific devices. These are all commonly made craniomaxillofacial devices. But this preoperative planning might have been done through 3D printing. And then this up here is a skull plate that's made of titanium. There was some trauma over here, and what they were able to do was mirror the skull down the middle and then duplicate what that surface should look like to repair any damage. And titanium is biocompatible, so your body's not going to reject it. And then it acts just like bone. And then the link for that's right here. This is another example where you can have like a 3D printed jaw implant. So this part is traditionally manufactured, right? They produce a bunch of these in different lengths. This part up here, it's kind of difficult to see. This is 3D printed. There's what we call trabecula structure up here, which is a structure that is designed to mimic the inside of bones. So I apologize for the low quality, but this is, get the laser pointer. This is a bone structure, or it's designed to help bone ingrowth. So it's planted next to the bones. It gives it a lot of surface area and also has that degree of randomness that the bone cells like to grow in naturally. So it helps to increase adhesion, right? So like the bone can grow into the implant and grow from there. This is a spine implant. This isn't that, but this demonstrates the structure that I was looking to show. So that's pretty neat. This is really, you can only really manufacture this with 3D printing. You can't really CNC that, all these tiny holes and random structures. It'd be very difficult to manufacture in conventional methods. So this is a really cool benefit of 3D printing. Something else now is that almost all 3D hearing aids are 3D printed. If you've ever had a hearing aid, what they do is they take like a model of your ear canal, they take that out, and then they can scan that. And then from that scan, they can turn that into a model and then print it. And you can see all sorts of different tips and inserts, all of these over here. And then these are eventually, they put the hearing aid components inside of these. So hearing aids went very quickly, I think in 2006, from being, everything was traditionally manufactured. They were all done by hand. Okay, we can take the ear canal impression and then we can go and we can 3D print the model to create, a hearing aid that fits in the ear canal specifically of the patient. So that's really cool, improves fit. And there's no waste and it's much quicker to do it this way. Oops. Something else, these are dental implant surgical guides. So, you have a model of the patient's teeth, you can do your preoperative planning, and then, hey, this is where you have to use your dental tools right here. So this fits like a glove right on top of your other teeth so that, there's one orientation, you put it on, and then you're able to put those holes and everything right where you're planning on them to go. So stuff like this, you don't have to drill another hole. You can reduce time that you're actually doing surgical operations, which improves patient outcome. These are commonly made with SLA, but Formlabs has a whole line of dental resins and technology and almost like a how-to do all of this for dentists in small practice. And then one last thing is preoperative planning. So this helps a clinician plan the procedure with a physical model before going into surgery, reducing time in surgery and improving patient outcomes along the way. So this is one example. This girl had some sort of defect with her aorta, and what they were able to do, the surgeon walked around with this model like on his person, in his briefcase, in his gym bag all the time, just so he had a model and could figure out where he was going to go. And in the article, they talk more about this, but the traditional approach would be to go in on the left side of the chest. They eventually figured it out. Hey, let's just go on the right side. Much smaller incision. We get access to everything we need to and go from there. So this was a very special case. Only one surgeon decided to accept this as a challenge. and go from there and help this little girl's life out. And then another one with this encephalopathy. This is a condition where the brain is formed outside of the skull. It's typically a very short lifespan disease. It's a birth defect. You're born with it. But this baby was born, and they found out that he was living. He decided to live for a couple months, and they're like, okay, how do we go about treating this? And the typical way is they just remove the portion of the brain that is outside of the skull. When they do that, obviously, for this specific case, the child was actually using all of his brain. So they couldn't just remove the portion that was outside of it. You can see it right here. So what they did is they took this child's scan data, made model after model after model, and they ran through this surgery a whole bunch of times, figuring out, the best way for them to do the approach to go about, just get it done in one shot. And they were able to reduce the time from, they estimated 15, 16 hours for the surgery down to 4, which is a 75% reduction in time in the operating room, as well as having the experience and confidence to know that you've done this before. Because they practiced on all of these models, right? If they weren't happy with something, they could practice until they got it right, until they were happy with it. There's a video here on this link that talks about that. But this was another really cool case where 3D printing was able to improve the outcomes. So that's all I have with regards to presentation matter. I guess, do you guys have any questions that I can do my best to answer? Is there anything that you guys find neat with 3D printing? Okay, well, if there's no questions, thanks for coming to my short presentation on medical applications of 3D printing. I'm going to stop recording.